Okay, installment 2 on area properties of integrals, and we're going to not going to do stuff so much analytically by hand because that's covered in the first video, but make sure you've watched that one. But we are looking at using some important terminology to help us distinguish important things, and the use of technology will be showcased because that wasn't done in the first video. So if someone says to you, find the area of the shaded region given at the left there, or if someone said, find the definite integral x squared take 4 dx between 1 and 4, aren't they the same question? Well, of course they are. Well, let's have a look. One method will give you 37 over 3 or 12 1/3 units squared, and another method will give you 9 square units. Okay, let's do that integral then on the calculator. Okay, so using a TI, we go into the calculus menu, we go to numerical integral, we enter in what we need to find. So it's from 1 up to 4, and it was x squared take 4 dx. And, oh, we get 9. Well, okay. And if we want to do it graphically too, we plot the graph. To generate the shaded region, we go to menu and analyze graph. And we look for integral. And carefully go, I've used an actual point there so I start in the right spot. From 1 through to 4. And it's a little bit fiddly, not as precise obviously, but I get 9. Okay, and I could zoom in and do that with more precision. That's if you want a picture of it. So, that explains using technology, and you could do it by hand, of course, how we get the 9. What about the other answer? Well, we can see that there's 2 regions there. We can see that the 2 regions are this one and that one. What if we had a problem where, let's say this was in meters or some larger unit, and we had to paint, we had to work out an area, we had to paint the 2 orange sections. What would be the actual area? Let's say it's in meters or tens of meters or something like that, and we had to work out the amount of surface there. So that's an area question as well, isn't it? Is the answer still 9? One way of doing it, of course, is to break it into the 2 separate areas. So we know we can do that with integrals. And let's do area 1 first and then area 2. So using the TI again, area 1 is a negative. So that's from 1 to 2. Well, that's interesting. And, well, what's area 2 is from 2 through to 4. So 2 through to 4. Oh, alright, that answer is bigger than 9, but this answer here is a negative, and I guess if we add those 2 together we make 9. That's how integrals work. But we can't paint a negative area. That is an area, it's just that it's hanging underneath the graph. So actual physical area that contributes is the positive of that. So what we actually have to do is the following. We grab that and we add it to this one up here. So remember, it was from 2 to 1. But physical areas are always positive, right? So we have to go ABS, absolute value. That's just my tablet getting low on juice, don't worry. I haven't broken any maths. We've got there. Okay, that's from above. I'm not pulling any tricks. See, 1 up to 2. Close the brackets, and we get 12 1/3. And is that not what I said we'd get? All right, 12 1/3. So that's the difference between the physical area and the area which is called algebraic. So there's a whole lot of synonyms here, so let's have a look at them. This is where the terminology kicks in. So if you're talking about the physical area, like the second question where we were painting, or sometimes it'll be called the total area, which is it's a little bit ambiguous, that phrase, I find. Certainly physical area, or if it's a physical problem where areas are always represented by positives, we have to use the absolute value on anything that comes out as negative, and that's why it's helpful to draw a graph first. Okay, you can identify the regions where the area region is below the x-axis, so regions where f of x is negative and where f of x is positive. Okay, and then we can split them up and integrate, and any negative regions in that sort of question would have an absolute value applied to them, so the sign always remains positive. The other sort of question, the algebraic type question, is where we got the result of 9, and so a positive area like area 2 has the opposite sign to a negative area, area 1. So for every unit squared above, it is counted by every unit squared below. And they're often called signed areas, because that's got a positive sign area and that one's a negative sign area below. And as I said, it's called algebraic area or the definite integral. Okay, so it's good to know those things, because sometimes problems ask you to determine which one that is, or need you to determine that. And also it shows you that you can do these things analytically by hand, or you can use technology such as the TI Nspire graphics calculator. Enjoy!